We're going to switch gears now and consider another class of policies that are widely used by the government to alter the outcomes generated by the market, and those are price control policies. And let me start by giving you a very high-level taxonomy of what these price control policies look like, and they can be categorized along two dimensions. First is whether it's a price ceiling, the policy involves a price ceiling, or a price floor. In the case of a price ceiling, basically what it says is that the price has to be less or equal than a price max. And the price max is the ceiling specified by the government. The price floor is a policy that says sellers can never sell or trades can never take place below a certain price. Okay? So the name is self-explanatory. The other is whether the policy involves a simple intervention or a complex one. In a simple intervention, what the government do is just impose the price restriction, and that's it. So just the price restriction. In a complex one, it does a price restriction plus necessary actions to clear the market. This is going to make a lot more sense what exactly a complex policy involves when I explain what happens in a simple policy. These simple policies are very common. An example of price ceiling are rent control for apartments. I suspect that many of you live in cities and may have even grown up in households that whose house were subject to rent control. They didn't pay a full market price. These price floors, especially with this complex restriction, is very common in agricultural policy. For example, the government may not want the price of some crop to fall below a certain level, and it imposes a price restriction and takes actions to guarantee that that is the case. These are just some examples. There are examples here too, but I'm going to skip them for now. In this video, we're going to focus on studying simple price restrictions. In the next video, we're going to look at the complex ones. So let's think for concreteness about the case. What is the case of a simple price ceiling? Now, there are going to be two potential cases, and what I'm going to draw in this here is a case where the policy binds. So the policy is not binding. You will see in a second what I mean. And here is where policy binds. So in both cases, I'm going to draw exactly the same supply and demand diagrams. So this is the demand in the market as a function of price. And let's say this is the supply as a function of price. It doesn't matter what the details really are, but I'm just drawing it like this. The key right now is that they are the same. Okay, and now suppose that we consider the introduction of a price ceiling. Sorry, in both cases, the equilibrium is this quantity and this price, which is the same. Now consider the introduction of a price ceiling, and one potential case in which is with the price ceiling, P max is greater or equal than P. In that particular case, the policy does not bind. It doesn't affect the equilibrium. You get the same equilibrium with once the policy is introduced. So this is equal to X star with P max, and this is equal to P star with P max. Why? Because the market forces are going to lead you to this price, which is below the price ceiling, so there is no problem. That should be obvious. Now, the case that is more interesting is what happens if the price ceiling is something like this. So in this case, P max is less or equal, that P star. Okay? So in this particular case, because of the policy, what we're going to have is that this becomes the new equilibrium price. because the price cannot go above that. But here comes the problem. At that price, suppliers want to supply this much, and consumers want to consume this much. So there is excess demand. The price is too low for the market to clear, and that means that not everybody that wants to buy at that price is going to be able to get. And this implies we need a rationing rule. Which specifies who gets the units that are produced that is less than the total demand. And a typical, the typical one that is used is something called an efficient rationing rule. Which says that the units are allocated to highest value users, highest value consumers. The idea is that if there are only that many units, you allocate the first one to the consumer with the highest value, the second one to the consumer with the highest value, given that, etc. So nobody with a higher marginal benefit for the unit than the ones that have it get it. Now, that assumption, this efficient rationing rule, makes a lot of sense if you believe that the effort that people will make, let's say by standing online or finding other consumers, finding clever ways to find the scarce units, is proportional to the marginal benefit that they derive from their units, which is not a crazy assumption. So what is the equilibrium in this particular case? In this particular case, we have that this is the total amount produced and consumed, and that the units are given basically to these subjects, to these consumers. These are the units with the highest marginal value. This is from the efficient rationing rule. So let's analyze the welfare effects of the binding price ceiling. Suppose we have the demand looks like this, the supply looks like this. This was the initial equilibrium price and quantity. Oops. And we introduce a price ceiling like this that is binding, and this becomes a new equilibrium. And this becomes a new quantity produced. And of course, we're going to assume the efficient rationing rule. Let me label these areas as follows: A, B, C, and D, E, and F. And I'm going to make a table here of what's the consumer surplus, the producer surplus, and the social surplus at the free market, at the price ceiling, and the change, the difference. Okay? So let's start with the free market. It should be obvious to see that the consumer surplus is A plus B plus E, that the producer surplus is C plus D plus F, and the social surplus is the entire triangle, which is A plus blah, 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 plus F. Okay? Now what's more interesting is what happens after the policy is introduced. Notice now that the producers can only sell this many units at that price, so the producer surplus now becomes that. So the producer surplus becomes D. Now the consumers get this many units with these marginal benefits because of the efficient rationing rule, and they only pay this much. So the surplus for the consumers is all of this. Is A plus B plus C. So what is the social surplus? Is A plus B plus C plus D. Okay. Now we can compute what is the difference between these areas, which means that is this minus this, so it's C minus E. So consumer surplus can go up or down. Consumers as a whole can be benefited depending on whether this area is greater than this or not. It's going to depend on the details of the problem. Now, what happens to producer surplus? It goes down by minus C plus F. Sorry, minus C plus F, like this. And what happens to the difference in social surplus is minus E plus F. And that is, of course, the deadweight loss introduced by the policy. So it's going to be this area. Now, let me make a couple of remarks. Clearly, when the policy is binding, it is inefficient because it produces this much loss in social surplus. Plus, please notice that there are cases in which the policy can have redistributive effects. So imagine, as we have been describing in previous models, that the people who own the firms are not the consumers. So there is a group of people who are firm owners and a group of people that are consumers. This policy entails a welfare loss, but also a sizable potentially transfer of producer surplus to consumer surplus. This C gets transferred to there. So potentially the consumers could be better off for the policy and could be highly in favor of it. And that may explain some of the politics about rent control that you see in many cities, New York City being the most prominent of them.